I'll sit here. Just because there's no one sitting here, and that becomes kind of thing. So I'm looking at the review packet. So we have 1 through 8 done. Are there any other questions on 1 through 8 that you need me to go back over? Take an honest look at the very front page. Is there anything on 1 through 8 you needed another example? Anything like that? Or you just wanted to see it reworked, or you're not quite sure why it worked out a certain way? Yeah. Do number 4? Okay. So number 4, do you want me to do the actual one, or do you want me to do a second one similar to it, or both? Okay. So that was what the actual question is. So I'm going to put, this is going to be a similar question. So let's go say -3 equals x over 7. Okay? So I want to get x by itself. So on this one, I would just multiply this side by 7 over 1, this side by 7. I get -21 is equal to x. You can flip this over if you want. Some people don't like looking at it that way. So that's how you would go about doing that kind of thing. Okay? You could have flipped this over originally. I could have made this problem look like this originally, and then done the math. It doesn't matter. I mean, if you take this side to this side and you just flip the whole thing over, totally fine to do. What do you got, bub?
Can you do another one of those?
Just like that? So here's another similar one. Let's go -8 equals x over 5. Okay? So what I'm going to do is I'm going to multiply, get rid of that 5. Those cancel, but I have to do it to this side as well. So I get -40 is equal to x. And then if you want, you can flip the whole thing over, again, to get the variable on the other side. You don't have to. It's just some people prefer to. Anything else on 1 through 8? We feel good? We're happy? Content? Is your neighbor looking funny? All right. So then we have completed 9 through 18 as well. Agreed? Are there any on 9 through 18 that you wanted to see a similar one or just rework one? 13? Okay, so you want me to do the actual one, or do you want me to make one up? Okay, so this is what it was, and we wanted to get this alone. Okay, so let's say I have this is similar. So let's do something with 3 variables in a while. Let's say we had c equals 2j plus 5m. And let's say I want to get j by itself. Okay? So we need to start moving things back and forth across the equal sign in order to make it work. So on this one, I'd subtract 5m from both sides. And c and 5m do not combine. The right side cancels out. But I get c minus 5m is equal to 2 times j. In order to undo 2 on the j, those are being multiplied. So I'm going to divide by 2. And yeah, it works. So that means that j, because those cancel out, is equal to c minus 5m all over 2. Is that okay? Cool. Anything else you would like to see? Yeah. The actual problem or a similar one? Okay. So 15, just so we know, is this one. And we're trying to get that alone, right? So this is a similar one. So let's say we had 5 over 7 equals x over 3. Okay, so this is basically, I'm going to cross multiply because I have 2 fractions equal to each other. So I'm going to go that times that, I'm going to get 7x. This times this is 5 times 3. So 7x equals 15. So in this case, divide each side by 7. Because I made it up off the cuff, just make sure it's a reduced fraction. I would imagine the one on the test would come out like a whole number, like 6 or 12 or something like that. And friends, you can use a calculator on this. You just need to bring one. I don't have them available. Okay? No, you can't use your phone calculator. Don't come walking into class, oh, I forgot my calculator. Well, good luck using your fingers and toes then. Is there any others on up through number 18 that I can help you with? Anything similar? We're good? Yeah. Yeah, baby. Oh, that's a good one to ask. Do you want number 11 actual or similar? Okay. So number 11, just so we know, is this problem. Okay. So a similar type of problem would be mm, 3 over 14. Okay. So the first step on this type of problem is clear the denominator. So what I'm going to do is the smallest number that both 7 and 14 go into evenly would be 14. So I'm going to multiply this by 14, this by 14 over 1, and this by 14 over 1. Okay? And if I do that, there's nothing to reduce here. I just have to multiply it. So I get x, 5 times 4 is 20, carry the 2, so I get 70. So this became 70x. Here I'm going to go 7 goes in 14 twice, and then I'm going to go negative 2 times negative 2, or negative 2 times 2. So I get negative 4x equals, these cancel each other out, so that leaves me 3. These are like terms. So I can go ahead and subtract them. So I'm going to get 66x equals 3. And then 66 and x are held together by multiplication, so I'll divide each side by 66. And in this case, I need to check to see if this will reduce. So 3 goes into itself once. 3 goes into 66 22 times, so 1 over 22 is my answer. And that didn't work out exactly how number 11 did, but same exact idea. Make sense? Giddy up. Yeah. 20. Oh, now you really jumped ahead on me. Hang on. We'll get there. Promise you. All right. So 1 through 18, we totally did. And then later in the packet, I did towards the end, wasn't it? Because it should have helped you with the quiz. So I think it was 55 through 62. 55 through 62, I think we're good with, because this is just the concepts we talked about. But that's also what we had done. Or wait, 54 through 62. 54 through 62, sorry. Okay, so this was, we just finished it. So far with review, we haven't gotten to everything yet, but let's kind of take a look. Today is Wednesday. Agree? Is it? Okay, pretty sure. I'll take that. All right, so Wednesday, Thursday, Friday. All right, let's play. We have not done, I'm going to kind of go through a couple problems, then tomorrow, if you want to see similar ones to these, please take whatever notes you feel appropriate for these. But I'm at number 19. If you wanted to see other problems done, we'll have time tomorrow to go through it, but I'll just run through, stop me where you have questions. Okay, so number 19, we have the absolute value of a quantity, and then we're subtracting 1 from that quantity. So what first thing I want to do here is I want to add 1 to both sides. Is that okay so far? If it's an absolute value, you're talking about a distance. So basically, you're figuring out, a distance from one way or the other. And one way or the other, I can go either way. So we have to break this into 2 problems. So the first problem we break it into is this. And then the second problem we break it into is this. So the main difference between the two is we don't have the absolute value sign any longer. we have one of the sides that looks just like the original without the absolute value sign. And then the other equation we have without the absolute value sign, but then we change the sign on the equation. Okay, so I'm going to subtract 9 from both sides on this one. So that's going to give me a is equal to -7. And I'll do the same thing here. So a is equal to -11. We need both answers. Okay. On the final exam, I will probably have one of those answers just by itself, like a equals -7. And then I'll have some other answer, and then I'll have one of the answers being a equals -7, a equals 11. Maybe the last answer might be a equals +7, a equals +11, something like that. So make sure you have two answers. So whatever notes you need to make to yourself, that an absolute value has to be broken into two problems without the absolute value sign. The side that doesn't have the absolute value sign, you change the signs on. Okay? And now I'm going to move down to chapter 2, number 20. Okay, number 20 says this. We have 24 minus 4p is less than -4p minus 3. Okay, we're going to treat the inequality sign like an equal sign for right now. Okay, so I need to make sure I distribute here. So nothing's changing on this problem. -4 times 4p is -16p. -4 times -3 is +12. We good so far with the math that's been done? All right, we need to now start moving things around. I might say I'm going to add 16p to both sides. You could have added 4p to both sides, but I just chose this first. So those cancel. There is some math that's going to take place. That's going to give me 12p right there. Okay, the inequality sign stays as is. And then I'm going to subtract 24 from both sides. So I get to that. Okay, those cancel out as well. Then I can divide both sides by 12. As long as what I'm dividing by, as long as this is positive, the sign stays the same. So -12 over 12 is -1. And so if I look at my inequality, I'd have 0, say here. I'd have -1 here. Because there's not an equal sign, it's an open dot, and I'm going to the left. Okay? So that's what it looks like. So number 20, which one looks as close to that as possible? Let's see, p is less than -1. We have that answer. It looks like it would be answer A on our sheet, I think. Yeah, because it looks like the other one, it's shading the wrong way. Good. May I move to number 21? Everyone have the notes they need? Okay. 21. -5 plus 5m is less than or equal to -3 plus 7m. Okay. So we want to get m on the same side. If I move the 5 over by subtracting it, move the 5m over by subtracting it, I keep a positive m value. Agree? So I might start with that. I might say, well, what happens if I go ahead and subtract 5m from this side and -5m from this side? Those cancel out. And that would be 2m. And then let's get 3 by itself or out of the way. So we're going to do that. So I get -2 is less than or equal to 2m. And then the last step, divide each side by 2. Those cancel. So I get -1 is less than or equal to m. This is kind of tough to look at. So flip everything, including the sign. Okay, and so on a number line, that would look similar to this. -1's here, 0's here. I'd have a solid dot. Hey, why is this one a solid dot? There's a little equal sign, and it's going to shade this way. So problem number 21, -1, solid dot. Looks like answer D. Okay, why is it not an open dot? It has an equal sign. Good. I think one of these is incorrect. I can't remember where it is, but we'll figure it out. Okay, number 22. Number 22, we have -4k plus 5 is greater than or equal to 21. So let's go ahead and solve this. So I'm going to subtract 5k from, or 5 from each side, excuse me. So -4k is greater than or equal to 16. Isn't 21 subtract 5, 16? So on this one, I'm going to divide each side by -4. So I'm going to make a note. Being I divided by a negative number, sign flips. So everyone is clear. This is my negative number I'm dividing by. Agree? So I'm going to get k sign flips -4. Okay, do you see how that flipped? Then I'm going to say, okay, I had -4 here. I got like 0 here. I have a solid dot. Agree? And I want values less than that. As long as the letter's on the left, you're solved for it. The inequality sign shows you the way to graph. So 22, k is less than or equal to -4. Looks like letter C would be the answer on that one. The big thing to note on this, friends, is this information here. Being I divide by a negative number, the sign flips. Okay? This all kind of starting to come back like something that we've worked on at least once. I hope. Number 23. I have 2x minus 6 is greater than 12. So let's go ahead and solve it. Add 6, add 6. 2x is greater than 18. Divide by 2, divide by 2. Those cancel. Reduce. X is greater than 9. We're not putting this on a number line. Okay? This is going to be a soft bracket. Okay, so it's going to start at 9, and it's going to go to infinity. And infinity also always has a soft bracket. Okay, so that's like looking at a number line, but that's how we do it. Soft bracket, it'd be a hard bracket if we had an equal sign on the 9. Remember, infinity always has a soft bracket on it. So 23, I have 9 to infinity, soft bracket on everything, so it looks like answer A. Can I go to 24? 24. Let's see. Is that 26 plus 6b is greater than 2 times 3b plus 4? Okay, so we're just going to distribute here first. Agree? Let's move the 6b over by subtracting it. So I get 26 is greater than 8. Notice the b's cancel out on both. Is this a true statement? Is 26 a bigger number than 8?
No. Well, yes.
So this is true. So this means answer A works. This is all real numbers. Okay? So sometimes that's different. Remember, like on when it has an equal sign, if all the letters go away, if you get a true statement, it's all infinite solutions. But this one, we had an inequality sign. So we're just looking to where the inequality sign is a true statement. If this was a false statement, this would mean we would have no solutions. Okay, so this is kind of a one to make note of. So maybe we could say something like, if all letters go away, then true is all real. False is no solution. Okay? Yeehaw, saddle up and ride. We're doing all right? What time are we out of here? Cool. I think I can get all the way through number 27, which would take care of chapter 2. Feel okay? Can I do it? Will you allow me to do it? I got this? Okay. Appreciate the support. All right. Number 25 starts talking about a compound inequality. Agreed? Compound inequality just means I have two different inequality problems. So I have 5x plus 10 is greater than 10, and 7x minus 7 is greater than 14. So one thing we have to remember, and means it's going to have overlap. And I'll explain what that means in a second. So I'm going to solve each of these. So I get 5x is equal or greater than 0. Divide by 5. X is greater than 0. So let's put this on a number line. So I have 0 here. I have an open dot here. And this is shading this way. Does that make sense? But then I'm going to do the other one, I'm going to add 7 to both sides. And divide by 7. So those cancel. So x is greater than 3. So 1, 2, 3. I have an open dot here, and it's shading this way. Okay, so friends, where do the green and the red start sharing? At 3. Agree? Does that make sense? So they start sharing here. So they start sharing. It's an open dot, so it's a soft bracket. Where's that arrow pointing to? Good. So number 25. You said and. Did I write it down right? I'm just looking for the answer. 21. Hey friends. X is greater than 0 and x is greater than 3. Oh, but you know what? The answer they gave you on that one, they have, first off, they have solid dots here and here at 0 and 3. We have open dots, right? So we don't have the answer on number 25. We made a misprint. So what I have graphed here is actually the answer. Unfortunately, I apologize that we made a mistake on our review. I hope that doesn't take away from your guys' education. If it does, you can write about it and tell me. It's because of you, I failed. What, me? I hope it's not because of me that you made a vital mistake. All right, number 26. I get negative 2, x is less than 2x minus 4 is less than 4. We good so far? Hey, does anyone remember what kind of compound inequality this would be? Would it be the and type or the or type? It's and. Remember, or always has what? Or will always say the word or. If you don't see the word or, it has to be and. So and means overlap, even though we can't make the problem right on the things. All right, so I'm going to take this middle section and I'm going to break this apart into two problems. So I have this one and I have this one. That's the first thing we have to recognize. Do you feel comfortable with that? Then let's see, add 4, add 4. 2 is less than or equal to 2x. Divide by 2, divide by 2. 1 is less than or equal to x. I might leave it like this for right now because I have to see what the answer is going to look like. Oh, okay. I'm actually going to flip this over because this will help us with the answer. Okay. So if I have like 1 right here, this would be a solid dot shading right. Okay. Remember, I'm looking for the overlap, but I'm just kind of writing it all up there. So let's solve this other one. Add 4, add 4. 2x is less than 8. Divide by 2, divide by 2. X is less than 4. So we have 4 like right here. So I have an open dot on this one, and this is shading this way. Where's the overlap take place on this problem? From 1 to 4. What kind of bracket do we put? So it should be soft here and hard here. Actually, I didn't even ask for that. But let's see, which one is this one? 1 and 4? 1 and 4. Where are we at? 1 and... Is that answer B? Sweet. Answer B works for me. Yeehaw. Saddle up and ride, folks. All right, number 27. Last one for the day. Good? You feel all right? And I don't think you would see one this complex on the test, but it's not going to hurt us to look at it. Okay. What kind of problem is this? And or. And, because the word or is not there. So this is going to go with both. So we're looking for overlap. So notice the middle went with both. We could just do this. We could say, let's add 5 to both sides. So I get 1 is less than or equal to 1/2 x. Multiply both sides by 2. So that cancels that. So I get 2 is less than or equal to x. So I might flip this whole thing over. And then second problem, add 5, add 5. Multiply by 2. Let's cancel. X is less than 20. Okay, so I kind of have to look at this on a number line, even though we don't have to graph it. So I have a solid dot going this way. 20. I have an open dot going this way. Okay, so my answer is going to be hard bracket 2 to soft bracket 20. Hard bracket 2 to soft bracket 20 looks like answer B. What do you think? So tomorrow, I think we could do 32 through 38 tomorrow. That's Thursday. And then Friday, we'll do 39 through 53. So somehow in the next couple days, and then what we'll reserve Monday for is anything in the packet you want me to go over, let's go over. Deal?